Hi there. My name is Neil McIsaac, and I'm a Microsoft Technical Trainer. As a data scientist using Azure, we'll tend to use the Azure Machine Learning service to train and manage our machine learning models. In this video, we'll learn what Azure Machine Learning is and get familiar with all of its resources and assets. In this video, we'll explore the Azure Machine Learning workspace. After that, we'll look at some developer tools for workspace interaction. And then we'll look at how to make the data available into an Azure Machine Learning workspace. Then we're going to look at compute resources in Azure Machine Learning. And the last thing we'll be discussing will be what environments are and how to use them within the Azure Machine Learning workspace as well. So let's get started with looking at the workspace and the resources and assets that we have available to us to do those machine learning workloads. So as we previously introduced in the first video in the series, the Azure Machine Learning service is designed to focus on training and deploying machine learning models. And the primary audience for this service are really data scientists. When we create a new Azure Machine Learning service in Azure, it comes with a set of resources and assets that we would use to work with our data and models. It's also important to remember that the Azure Machine Learning service is still within Azure and is governed by the architecture of how services are managed within Azure. So a couple of things here. First, our Azure Machine Learning service is depicted on the slide here as a beaker kind of shape, marked with the number 4. Above it, we have a resource group, since every resource in Azure needs to belong to a resource group. Above that, we have the subscription. The easiest way to describe the subscription for those that are new to that is that subscriptions are the way that we essentially pay for services. So an organization could have multiple subscriptions for different purposes, such as a subscription for production and a subscription for development and testing. And this can also provide a management separation as well. Above our subscription is really just Azure itself, which is represented here as the cloud symbol. So that's what's above our service and describes the space that our service works in. When we provision the service, we get 4 related services, really 3 plus an optional one, that are provisioned when we provision our Azure Machine Learning service. Those services are an Azure storage account that's used to store all of the metadata and artifacts directly related to our service and can be used to also store data that we could use for model training. However, it's pretty common to connect to other data sources such as other storage accounts or data sources such as databases from our machine learning service, which we'll look at later on in the course. We also need an Azure Key Vault. The Azure Key Vault service is used to store secrets, and it's a really common service that we use across Azure to store secrets for lots of other services and applications. With respect to the Azure Machine Learning service, the Azure Key Vault is used to store things like usernames and passwords and connection strings for data sources that we need to connect to. The next service that's required is Application Insights. This service is used to record all of the telemetry so that we can monitor our deployments using a service that's designed for that specifically. The last service here is the Azure Container Registry, and this one is optional when we deploy the service. That being said, we almost always want it. This service is used to store container images that we use for providing environments, right, to the Azure Machine Learning service. When we provision the Azure Machine Learning service, we can see and manage the service within the Azure portal, which is what the image on the slide is showing. There are some things which can be easier to manage with this interface, such as managing permissions to the service by configuring the access control settings. However, most of our time will be spent in the Azure Machine Learning Studio, which can be launched using the Launch Studio button or by using the Studio web URL in the top right corner of this interface, which connects to ml.azure.com. In this course, we'll be spending most of our time in the Studio interface. Let's go over to the Azure portal and see how to provision the service and get a brief introduction to the Azure Machine Learning service in the Studio interface. All right, so the first thing that we want to do is go and create the resource, right? So let's go up to create a resource in the Azure portal. And we're going to go search for the Azure Machine Learning service. So let's do a quick search here. Close some windows. We can see that it's right here, so let's create that and get this going. And so we're going to put this into a resource group. I'm going to make a brand new one. So let's call this, how about RG DP-100 Labs. This is really just to organize our resource groups. Let's give this service a name, which for this one, how about Neil's demo maybe, or let's change it to DP-100 demo. There we go, even better. So we can choose what region, so where in the world this is going to exist. I'm a little partial to this one, so Canada Central. And here are the different services that we need to create with this. So these are the 4 services that I mentioned. We have the storage account, the Key Vault, the application insights, and container registry. And the storage account, of course, is really important. So all of these are listed in here. And the first 3 we really need to have, but you'll notice that the container registry is marked as none. So if you don't have one, these all default to being new, right? So you can see that if you did have an existing storage account, you can drop that down and select it. And the container registry, of course, is optional for that. The next thing we have is networking. So we do have options to make the service very private if you want to. That's common, but we're going to leave that as public. And then encryption. Encryption is really big for us. Notice that there's no option to say no to encryption. It's either Microsoft managed keys, and it's all about storing those metrics and the metadata. It is actually in the Cosmos DB instance. So this is like the core things for the service. And of course, everything is encrypted to us, whether it's in storage or anything. So you can choose between Microsoft managed keys or customer managed keys. And the customer managed keys are where you provide your own keys, and that helps with the security quite a bit. The next thing we're going to jump to is the identity. So if we used our own services instead of creating new ones, we would actually have to set up the security. So any of those existing storage accounts and all that, we would have to set that up so that this service would have access to those other services if they were already provisioned for it. So let's jump into the last little bit. So all of the services in Azure really support tags, so we can apply metadata to everything, so we can identify and help manage it later. So you can fill these out if necessary. And then, of course, the last stage to really create everything is to review it, make sure that the validation has passed, and then we'll go and create the service. So this is going to take a little bit to create, because one of the things about this creation process is it does have to go through and create the other services. Remember that we set the storage account and the Key Vault, et cetera. We set those all to be brand new. So when this is being deployed, those services are being created first. The storage account is being created, the Key Vault is being created, et cetera. And then lastly, the machine learning service will get created after that. So let's get this creating, and we'll just wait for this to go. It shouldn't take too long, but it will take maybe about 2 minutes or so. Since this video has been pre-recorded, we've sped up this section to save you a bit of time waiting for this to complete. All right, so we can see that the other services are all created, the App Insight service, the storage, the Key Vault service. We're just waiting for the machine learning service itself to be created lastly, and then we should be good to jump into the service to check it out. All right, there the deployment is complete. So let's go check it out. Let's go to that resource. And as soon as we open this resource, the page that we're on, this is the Azure portal interface to this resource. So, we do see that the name, it is the Azure Machine Learning workspace, and we have the kind of the standard portal interface. So things like the overview, all of the different settings. This is a new interface where it's all collapsed now. So you will have to expand these for settings, monitoring settings, and all that. The thing is that this is something that you'd see for pretty much all services. The menu changes a little bit, but it's pretty common. Now, another thing is that we will be using the Studio service quite a bit, the Studio interface rather. And just to point out though that something that you can do here is manage the access control. So just to highlight where this is, we talked about these role assignments earlier. So we can add the role assignments to grant somebody access to this service. And this is going to happen in the portal interface. We'll come back to the Studio interface in just a second. So the way you would do this is simply add the role assignment. You can grant the data, the Azure ML data science role or the compute operator role, to be a little more granular permissions. You can go to the custom role. On the overview page, coming back to it, so like I was saying, the Studio interface is the one that we tend to use the most with the Azure Machine Learning Studio, and that'll take us to another interface. I do want to point out that this is just a URL really, and the URL is right up here, right? So the Studio web URL, it is ml.azure.com. This URL gives us also the identity of this workspace, but it's actually possible that you can just go to the ml.azure.com website and then select the workspace when you log in there. So, either of those are fine. So both of these, either the URL here or that Studio button down at the bottom, is going to take us to the Studio. So let's use that Launch Studio. And off we go to a brand new page where we are now in the Machine Learning Studio, right? You'll notice that the interface is quite a bit different. This is very much a purpose-built interface for what we're doing. There's a lot of stuff for generative AI in here. In this course, we're not going to be talking much about it. That's a whole world in itself. We're going to be focusing on building our own models, and so the home page, to get us started. There's a lot of different bits in here. There's coming down a little bit, notebooks, where we're going to do a lot of our authoring for this. So we tend to, as a data scientist, we're going to spend a lot of time on this. So let's just close that, what's new. And we can look at our file system here and go, there's nothing really here. But as we go through the course, we'll see a lot more. So we're also going to talk later on about automated ML, right? So we're going to show you this with a script, but this is where we can do automated training jobs, and we'll talk about what that is and all that. But that's also very much supported here, which is going to be great. Now later in the course, we will talk about like components and pipelines and everything. And there is another interface here for the designer, and so let's close that. This is where we can actually use components in a graphical interface to kind of drag and drop and connect things together. I'm going to show you pipelines and components with more with scripts in it. It's actually, I think, kind of easy to play around with that. All right, next up, data. Right, it's a big part of this. So let's take a quick look at data. We see that we can control our data assets and data stores in here. Then there's some more ability than what we're going to talk about, but data assets and data stores are really the foundation of what we're going to be working with, kind of day to day. And so so data is going to be a big part of that. All right, let's jump down to compute, the other side of it. So we have data, we need compute, and here you can see that we have 4 bits of compute that are listed here. So compute instances. And compute clusters and the Kubernetes clusters and the attached compute. So we can configure all this. Compute instances, of course, are going to be the one that we use for data scientists to kind of work with our data, right? All right, next up, jobs. So when we have a script that we want to run routinely, like on a schedule, we're going to do this under a job. And We can do this with scripts, so we can schedule them, all that good stuff in there to get the work done. So, things like training and all that have a lot of steps. And it makes a lot more sense to simply queue up a job to do that, and that way we can walk away and do other things while that's going. And of course, the diamond that we're really trying to get to is to have a really good model. So this actually supports, registering models under this list, and we can have those models there that are deployed. So think these are the ones that kind of bubble up to be the best ones that we want to use, and we can see it on this list here. Even though we can have a lot more models in storage and all that stuff. And of course, once we have that model that's all approved, we need to host it, to deploy it, and we're going to use endpoints for that. And again, we're going to talk about these all this stuff later on. But here you can see that we can do real-time endpoints, we can do batch endpoints. Right? We also have, when we're talking about compute, we'll talk about compute more later on, but serverless endpoints, there's a lot more serverless options in here. And even though serverless says, serverless, like there's no server behind it, I think a better phrase is serverless really means like compute on demand. It's just a lot longer to write that, and it doesn't roll off the tongue as well. But it's a great new option to have for all this. So it's so we can get our stuff hosted. Now, lastly, you see the Azure OpenAI mark there. And back here on the home page, we also have all the generative AI models. These models are pre-built. And we can do things like prompt flows and everything with them. Again, in this course, we're not really going to focus on any of that. So, all right, with that, that's a quick overview. Let's get back over to some content and talk more about all this stuff. So let's see what's going on. So when I was showing how to provision the service, I showed it using the Azure portal interface. However, you can also create the workspace a number of different ways, such as using the Azure CLI, which is the Azure command line interface, or we could use ARM templates, or we could do it using the Azure Machine Learning Python SDK, which you can see an example of on the slide here. We'll explore the developer tools a bit later in this video. Earlier, I mentioned that you can set access to the workspace by configuring the access control in the Azure portal. We have 3 common roles that we can set on any resource in Azure. The owner role, which gets full permissions to the resource. We have the contributor role, which has all the permissions of full except the ability to manage permissions. So this is actually a very privileged role. And we also have the reader role, which, as the name implies, allows people to view the resource, but they can't make any changes. We also have 2 unique rules that are specific to the Azure Machine Learning service. These are the Azure ML Data Scientist and the Azure ML Compute Operator. The Azure ML Data Scientist rule can do everything in the workspace except for managing compute resources or editing the workspace settings. And the Azure ML Compute Operator role allows somebody to manage any of the compute resources in the workspace. The reason why these 2 roles exist is because our largest cost in cloud computing, as well as within our Azure Machine Learning workspace, tends to be compute. It's not uncommon for an organization to have data scientists that are really knowledgeable on data scientists, but not as knowledgeable about managing compute resources in the cloud. When that happens, compute resources are often misconfigured and can result in driving up costs. For example, maybe they're left on running when they shouldn't. So to help avoid this, we can assign people that are well-versed in managing compute resources to the Azure ML Compute Operators role, and they can manage all of the compute for the data scientists. The last thing here is that if you want to be very granular with permissions, all you need to do is create a custom rule where you can define specific actions that that role can perform in your Azure Machine Learning workspace. It's important to be able to work with the Azure Machine Learning service in many different ways. So although we can use the portal interface, which we just looked at, we can also use the Python SDK or the Azure CLI to manage our service with code. So let's take a look at that. Here's a quick example of using the Python SDK. To get started with it, we'll need to do a pip install of the Azure AI ML library. After that, we can connect to the workspace using the sample code here that uses the ML client class to connect to the workspace using our credentials, subscription ID, the resource group that our service is provisioned in, and the workspace name. It's possible to connect to our workspace from anywhere that runs Python. So for example, this code could be executing from a desktop computer outside of Azure. In this course, you'll see many examples of using the Python SDK to manage our machine learning service. Another way to manage our services is by using the Azure Command Line Interface, or CLI for short. The CLI is primarily used by Azure administrators and engineers to help automate the creation and management of services, usually within things like CI/CD pipelines. This helps to make sure that the service is deployed and configured efficiently and can be repeated if it needs to be redeployed or recreated in another environment. When we install the Azure CLI on our computer, it doesn't come with machine learning support out of the box. So what we need to do is to add the machine learning extension by running the AZ extension add command and adding the machine learning support. Once we do that, we can then use the AZ space ML command to manage our machine learning service, such as creating compute in our service, which is what the example in the slide here shows. Now, let's see a quick demo on how to use the Python SDK and the Azure CLI to manage our service. All right, so let's first think about creating a resource. In the last demo, we went and used this create a resource button and used the graphical interface to do everything. This time what we're going to do is go over to the Cloud Shell because we want to do this in command line, right, doing code. So we're going to open up this bash prompt. What I'm about to show you, I can show in bash or PowerShell, so it really does matter. Once we're here, the first thing that we need to do is, if we want to do the Azure CLIs, we need to add the extension. Now, I'm going to show you how to do this, even though the Cloud Shell already has this extension added for us. But the command that we would do is AZ extension add -n ML, right, for the machine learning name that we want. And it just kind of comes back and says, hey, it's already installed, and we can see the version. So even though we can do this here, it doesn't really matter because it's already installed. However, if you were to do this on your own computer at home, you would need to install this extension. It doesn't come with the Azure CLI included. It's not included with the Azure CLI already out of the box. So it's just a matter of running that command, though. Okay, so after this, let's actually see how to do everything with the CLI. So I'm going to start off with the AZ group command to go and create a new resource group. So this is a blank subscription here. There's no machine learning anything here, and so I'm just going to create this. Let's call it RG-DP-100-labs. So similar to what we did in the GUI interface earlier. And we give it a location, if I can spell it okay. And so let's just put this in East US. And so this should create very quickly because it's just a resource group. And we're going to need the resource group so we have somewhere to create the machine learning workspace. So the command I'm going to use now is azml space workspace create. And when we add the ML extension, it gives us the ability to do azml commands, right? So it adds that part of it. So let's give it a name here for our workspace. Let's call this DP-100 demos, like we did in the previous video. Let's just do demo. And we need to specify what group we're going to put this in. So in this case, it's the resource group we just created. And because we didn't add anything else to the command, it's going to just default a lot of the things. So remember that we still have all those services that we need with storage. We have the storage account, you can see being provisioned here, but we also have the Key Vault, we have the App Insights, and the container registry was optional. So we're just going to get the required stuff. And it's just going to match our name and do that. Now, I could have added all of this to the command. I could have went in and said AZML workspace and added the different parameters to be more specific with what I want to happen or if it's existing. But I'm just going to keep it simple and just use the defaults for this one. So that's going to take a little bit to create, similar to creating it in the graphical interface in the GUI. We just need all these services to go through. So let's let that happen. That's going to take a minute or two. So now we can see that we're onto the log analytics workspace being created. The log analytics workspace, by the way, is the app insights, right, service that we see in the other interface. And now it's we see the key vault. Right? And the log analytics workspace, is really the one that's behind the app insights service. So just to be a little clearer on that, both of them are kind of required there. And then lastly, we see the Azure ML workspace being created. All right, there we go. So now that this is created, we can go and look at it in the portal interface. Let's pull that down a little bit. We can see our resource group. And with that, we see our other services, but right there we see our machine learning workspace, right, with everything else. Now, once that's created, things don't stop there. We can do a little bit more with the command line interface, the CLI here. So let's do another one where we're going to create some compute. Now, this compute, not just a general virtual machine in Azure, this is going to be AZ space ML. So we're creating compute in the machine learning workspace. So let's give that a name. So we'll just say Neil's compute. We'll give it a size. Now, one of the things about the size is you may be wondering, well, how do we know what sizes are? These are standard sizes in Azure. So what sizes are supported with their compute? And so we could just look that up, and we would tend to be somewhat familiar with them. We want to give it a type as well. So what type of compute are we doing? This is going to be a compute instance. We need to specify what workspace we're using. So this is our DP-100 demo workspace that we just created. And we need to just tell it what resource group it belongs to as part of the command. So that's going to be RG DP-100 labs. And at this point, this will run off and create a new compute instance in that. So the point is, while this is running, is that we can use these CLI commands to go and provision these resources and everything in our workspace. So, create the workspace, create all the resources, and really drive managing. It's going to be great for, that CI/CD type ML ops workflow type stuff, right? So, all right, this is going to take a tiny bit to run. So let's wait for that to happen. For those of you that are watching the recorded version of this course, we've sped up some of the video to save you some time. The typical wait for this can be much longer in real life. There we go. All right, so that's complete. So that's, again, off into our machine learning workspace, already done. You see the state is running, so all good. All right, let's do something similar now. I'm cheating a little bit. I've actually just copy and paste the same command, but what I'm going to do is I'm going to change a couple things. So we're going to make some more compute. I'm going to change the name here to be AML cluster. And one of the big differences I'm going to make is that this is no longer going to be of type compute instance. I'm going to change this to be AML compute. And what that's going to do is create the machine learning compute cluster instead. So we do need another parameter in here. So the maximum number of instances, we're going to set that to 2. That way it's going to help control our costs, so it won't scale up to a really large number or anything. And let's get that creating. Now this actually creates a little bit faster, and the reason is because the clusters are shut down. So this is really like a definition that's being deployed. These don't really get created until we click the run button. And it's really when we have a job going against it, and it spins up. And so it's not creating the compute instance, not the same as creating the compute instance, where it's creating a lot more that needs to be running, for example, possibly running all the time. This is really much more like on-demand compute. So this shouldn't take too long for that. There we go. So a lot quicker than the other one. We now have a compute cluster in our machine learning as well. All right, let's put this away. And let's go over to our machine learning workspace. So we're going to go into the studio view for this. Let's just close some of these up. You see that our compute was created, so we do get a notification in here as well. And so let's come down to our compute. Yeah. And let's take a closer look at the Niels compute. This is the compute instance that we did. And just so you know, the compute cluster was created as well, so it is there. So on the compute instance, when we're talking about doing command line stuff in here, we can use this compute instance to do a lot of the work in machine learning space as well. So we can manipulate file. We can use it to manipulate files and everything. So working with it now, there's a little sort of hidden bit with it though. If we want to really access this this compute, so you notice that on the right hand side there's a number of applications over here, right? So this is how we can communicate with it. So we have like the Jupyter Lab, Jupyter interface, working with it with like VS Code and everything. But if you come over just a little bit to the right, so they're all listed here. This is where it's, all right, so you see them all. A little further to the right there. If we expand that, we see that there's actually a little bit more, and the two that we want to probably work with would be terminal and notebook. And so, so we can actually use these, again, you think run commands, it's going to run within that compute, but we can do it to do command line stuff. So I just opened up the terminal session, and you'll notice that it is logged into the Niels compute instance, and I can start running commands here. Now, this will have access to files and everything in the machine learning workspace. So if I want to run a script, for example, I absolutely can. So for just to show, we can do a pip install. And one of the things about this, so when we're talking about this environment, we talked about the Azure AI ML library. So it's just going to make sure that it's not installed. So we're going to remove it, and then we're going to do a pip install of the Azure AI ML library for this. And just to sort of show a point here is that when we do this, now once this library is installed, I can turn around and run commands, right, against that library in Python, right? So think the Python SDK. This is how we're going to get that really set up here. All right, so that's all there, and since it's there, now we can start really taking advantage of whichever version of the Python SDK we just installed. So one of the main things that we like to do with all of that would be to run notebooks, right? Let's just clean this up a little bit. I'm just going to grab a command here. So to show you the notebooks, I'm going to do a git clone command. And what's interesting about this is even though it's running within this compute instance, which is essentially a virtual machine, it's actually going to be using the storage that we have mapped to our workspace. And so this is going to pull down everything from the workspace. By the way, this repository that I'm using actually has a bunch of these notebooks that I'm going to be using to demonstrate a lot of the stuff in this course. So if you want to use this same repository, you can pull it down and use it as well. So all right, now that that's there, you notice that I can refresh the files and I see what I just pulled down, right, with the git clone command. And so I have all these notebooks, from these labs that we have with our DP-100 course. We have a lot of content out online in general. So once we open up the notebook, a standard notebook interface in here, all right, so we can do things like, run a training script, whichever one we want to really do. We're going to be working with notebooks kind of throughout the course, so we're not going to explain, all the details of this one, just yet. And but you can see it's a standard notebook, so there's nothing really that special about it in here. Notebooks are just awesome generally, but it is going to be backed with the Python SDK because it's running in the compute. We need to attach it to compute, so it's going to run in that compute that we just provisioned, for that. And we can, if we have access to multiple compute instances, we do want to make sure we're connecting the right one. Now, you notice I just hit the authenticate button. When we first open up a notebook, it does need to be authenticated against that compute, right? Sorry, not the compute, but I mean the Azure, right? Against Azure. So when we're doing anything in here, making sure that the notebook, in fact, the Python SDK has been authenticated over to the Azure interface so it can communicate with our machine learning interface. We made that improvement so it's a little easier to just hit the authenticate button. All right, so I'm running some stuff here and just show you that we're going to get down to using the Python SDK, right? And so I just ran like the whole notebook in here. And this spawned a job. So like now that we've authenticated all this stuff, it works, right? We can communicate to the machine learning service just fine with that. All right. So that first command, just so you know, is just making sure that we have the Azure AI ML library already installed, right? And that's one of the things that we installed a minute ago. And we can see what version it is and all that good stuff. And it works. All right, let's get back to some content and talk about some more stuff. Of course, we really can't do anything with building models unless we have access to the data. In this section, we're going to look at how to configure those connections to our data using URIs, which are Uniform Resource Identifiers. We'll also look at how to configure data stores and data assets and why we use them in our Azure Machine Learning service. Let's get started with URIs. URIs are references to the location of your data. This will always start with the protocol of the service that we're connecting to. So for example, we would use HTTPS to connect to an Azure storage account, or maybe an external public location. When we're connecting to Azure Data Lake Storage, we would use the ABFSS protocol, which stands for Azure Blob File System Secure, which allows us to take advantage of the additional features of Azure Data Lake Storage. And if we're connecting to the Azure ML data store, we would use Azure ML at the beginning of our URI. One thing worth mentioning here is that by storing the connection information to URIs, as well as data stores and data assets within the service, we can avoid having connection information in our code like within a notebook. Although we can connect to data assets using a URI, in most cases, it's better to use a data store. The reason being is because data stores can encapsulate the connection information to the data. That way we can better protect the data, since the data scientist that would be using the connection within things like notebooks wouldn't need to have the connection information. The other reason for this is just that it makes everything much easier, since we can connect to a data store more easily, especially if we're using the same data store over and over again. There are also 4 built-in data stores that are created when you first create the machine learning service. 2 of these connect to Azure Blob storage containers, and 2 of them connect to Azure Storage file shares. All 4 of them connect to the storage account that was created or assigned when we first created the service. These 4 built-in data stores are primarily used by the Azure Machine Learning service to store system information such as its metadata. It's important to realize that data stores just point to a data location, but they don't define any of the details of the data that you'd be working with. For that, we use data assets. Data assets can go a step further than data stores by providing specific information to the actual data. For example, we might build a data asset that points to a data store that provides the connection information and the overall location of that data. But then we can use a data asset to go further in specifying the specific location, such as a folder, that the data lives in, as well as the type of data that's being stored there. This way we have the ability to use a data store to store multiple types of data, and we have multiple data assets that can point to multiple locations with different types of data in that one store. For example, maybe one data asset is sales information, and another data asset is customer information. And both of those assets could be stored within the same data store where it's actually physically stored. Data assets will point to either a URI file, which represents a path to a specific file, a URI folder, which represents a path to an entire folder, or we can create a data asset that points to what's called an ML table, which represents a machine learning table. ML tables are basically a file or folder path, but it also has the schema definition with it, so that the machine learning service can read that data as tabular data right away. Data assets also support versioning because, as we all know, things change over time. All right, let's head over to the Azure Machine Learning Studio, and we'll see how to work with data stores and data assets. All right, so let's look more at the data. So let's start off. Let's go over to the resource groups and see our resources here in Azure. So back into our resource group. And this is the resource group where we have our Azure Machine Learning workspace. But notice that we have our storage account that it's connected to, but it is external to what we're doing. So let's open that up. And inside of here, this storage accounts are very ubiquitous across Azure. We use them all over the place for all kinds of different things. And so we have things like containers and file shares and queues and tables. And our interest is really going to be containers and file shares. So we'll look at containers here in a second, right? But file shares are right below that. And so we do have a storage browser as well. So it's a little easier to kind of look to see what's in here. And with this one, let's just take a quick peek at the blob containers that already exist in it. And I just wanted to point out that there's a number of things that are already here. So you see the some things there. You see under the file shares, a couple things that are already there as well. So when we provision this, the Azure Machine Learning Service really provisioned all of these pieces. All right, let's go back. Let's take a look at what we see in the machine learning service. So let's open this up. And of course, we're going to jump to the studio. So switch interfaces here. And let's come down to data, right? So let's get rid of that. So I mentioned before, we're talking about data stores, data assets and data stores all the time. So let's go over to data stores, and there's 4 data stores that come provisioned with the service. So this the workspace working directory here happens to be an Azure file share. This is what we were basically looking at. So this is the name locally here, and we have the artifact store, the file store, and a blob store, right? And this is the default storage. Notice it's marked to default, but all of these are from the storage account that I just showed. So even though the names seem a little bit different, these are actually pointing to those different, the blob containers and the file shares from that storage. So it is possible to go back here and play with it. So for example, if we wanted to go and do a brand new container in here, we absolutely could. Storage can contain a lot of content. So let's call this new container training data and go ahead and create that. And then, later on, we could use this container to actually store data afterwards. So if we're, we have training data, anything like that, we can store it. We can actually use it from the machine learning workspace. All right. So now, one of the things that we're going to need in a little bit, and something I want to show you, is I want to have the access. I need the access keys to this, and you'll see why in a little bit. So let me just copy these. So I'm going to grab the storage account name. I'm also going to go and grab the key for this, right? So I'm just going to use access keys. Ideally, we do this with like identities, and there's a way to do that, but it's much more complicated to show. So, so I'm going to cheat a little bit and just use one of these keys. So I'm just going to record this quickly. All right, now at this point, there we go. I almost forgot to paste that. So just putting them on another screen. So at this point, if we go back into our studio, the idea here is that I can create another data store that points to that container that we just had. So let me come down and grab a notebook, one that's already set up for me. The last thing you want to see is me to type in an entire notebook. So a couple things we're just going to do for the plumbing. We want to make sure that the Azure AI ML library is there, so make sure it is installed. So that's all good. We're going to connect to the workspace. This is going to make sure that our credentials are already verified for this notebook to talk to the Azure Machine Learning workspace. So that went okay. And then this one, we want to make sure that we have this ML client, right? So this is something that we use a lot in the Azure Machine Learning workspace, and pulls up the configuration for everything. So we just have this ML client object that we can use. Now, once we have that, we'll tend to use this object to work with the machine learning workspace. And in this case, we're going to be playing with data stores, right? So it's important to understand a lot of the machine learning environment to work with these spaces. So this one, we're just going to list it. So let me just run that. And we see currently we have the 4 data stores that we showed earlier in the portal interface, right? All right, so the plan, though, is that we want to create a new data store. And if you remember, data stores are going to be basically like connections over to storage somewhere. So it's not the specifics of getting to the file, it's like where it is and how do we get access kind of to the general storage, wherever that is. And so this one, there's a little blurb in here to create a new Azure Blob-based data store, and I'm just going to pop in the account name and the account key that I copied earlier. And just while I'm doing that, if you look at the code here, you'll see that we're giving this blob data store a name. Let me copy that. Yes, we copy. We're giving it a name. We're also pointing it to a specific container name. That's the training data container that I just made a minute ago. right? So the name of the blob in the data store can actually be different than the actual name of like the container or the folder or whatever that we're pointing to. Last thing we need is we need the account key. Normally I'd say don't copy my key, but I'm going to delete all this in a minute anyway, so I wouldn't worry about it. And let's get that creating. Right, so this goes fairly fast because it's just the like connection type information. So that was successful. Now if we go back and we list our data stores again, we can see that we now have the blob training data that points to that container that I just created. All right, so that works. Now, the next part, actually, let me go over and show you the data stores right here. So you can see that it shows up in the data stores tab as well. I almost forgot to show that. So the next part we want to do is look at creating a data asset. Now the data asset is really the connection to that specific file or folder. So we can go to a specific file, to a specific folder. We can connect to an ML table, right? So we'll talk a little more about that. And this is going to use a data store. Typically uses a data store to kind of get connected. It doesn't have to though. So in this one, we see that we're just setting up a path. Say there's my data. The asset type is going to be a URI file. So it's like, yep, direct connection to a file. We're going to give it a name, and this is just going to be in the the default store here. So so we could run this, right, and get that connection over to the diabetes data. So at the very bottom of that, of course, and by the way, yeah, this is when we create this, I should mention this. This is going to be like uploaded to the default data store. I said it was just in it, but it's actually uploaded. Just misspoke a little bit. So yeah, so there it is. We also get a new path. So if we're looking at a path like to HTTP or anything like that, we do get a new path to it. It's now part of the Azure ML space as a data asset. All right, next one, let's go to URI folder. And this is going to be very similar, but in this case, we're going to point it to the blob training data folder that we created earlier. This was just a folder. And so because it's a data asset, it starts with the Azure ML name. There's the path to what we want. We need to make sure that it's marked as URI folder. And that's good to go. So we just create that. And I think this is a pretty good combination of showing a data asset with the data store with the data asset together to say that's where it is. These are the details of like what folder, what file that we want. And now it's an object that we can use in the machine learning service. All right, the last one. The last one we're going to do is to create an ML table, right? Now, earlier we talked about ML tables. This is where we have an ML table definition. So let me come over here and just show you a little bit of that. So just up into so from there, it's going to be just under the data. And notice there's an ML, not just the data, but there's an ML table file right there with it. So we need both of those to really support this one. And again, the ML table is, it stores the schema in there. So so that right there is going to store the schema for this. It's going to describe it. So let's run this, and we're really getting another data asset with the name diabetes table, but it is of type ML table. And there's a lot of services that actually, a lot of different features in the machine learning service that actually require that. All right, now let's look at our list of data. Here it's listed as data sets. In the interface, it's data assets. Same thing. And we see that diabetes local, the data store path, and the table are all there. All right. So something like the ML table, we can read it, and notice it just gets easy to read because we just refer to the Azure ML space and say, hey, what's the ID? There's the data asset and the ID for it. In this case, we want to get the one for the diabetes table. And so That's the registered data asset that we're using in here. But notice the protocol is just Azure ML, basically saying it's the local one in the machine learning service, right? In this case, a data asset. So let's run this, and we see that we should hopefully get some data returned. All right, there we go. So we had a table put out as a pandas data frame, and it looks pretty good. Now, of course, when we're doing, the reason we set up all the data is because we want to use this all over the place in the machine learning space. So we can use this in a job, for example, and work with it. So those data assets, right? All of these become a lot easier to use, right? Because now we can use them basically by name. We don't have to worry about the connection information, all that stuff in the notebook. All right, with that, I think that's a pretty good overview. So let's jump back into some content, and let's talk a little bit more about next up is going to be compute. All right, let's talk about compute. Compute is one of the most important resources that we use within our service, since we really can't do anything with the data without using compute. The overall challenge here is to make sure that we're using compute efficiently. The main reason is because this is one of the most expensive resources that we use. But also, specifically for larger scale projects, we also want to get our data processed and our models trained in a timely manner. So let's take a look at how to configure compute within our workspace. Within the Azure Machine Learning service, we use seven different types of compute. Here on the slide, we can see how these different types align with the machine learning task that would use it for, within the workspace. So let's talk about the different types. Compute instances and serverless Spark are used to back notebooks so that when we're executing code in the notebook, the code will actually be executing within one of these compute environments. This aligns with doing experimentation in the machine learning process. A compute instance is essentially just a single virtual machine. These are assigned to individual users. Serverless Spark is a newer feature of the Azure Machine Learning environment that lets us perform Spark-based workloads, such as running notebooks, more efficiently. And as an added bonus, we don't have to configure the compute environment for it like we would to create a compute instance. However, serverless Spark compute does have some disadvantages. For example, it only supports in-memory SQL, Spark SQL. So there's no support for Metastore-based tables or databases. We can't consume any linked services that we would have in the Azure Machine Learning service. It also doesn't support pool-level configuration or library management. So if any of these restrictions would affect your use case, you can simply go over to the compute instance instead, since you're given full control over the compute environment with that one. Moving into the middle of the slide, we see compute clusters, serverless compute, and Kubernetes clusters under the machine learning activities of model training and running pipeline jobs. A compute cluster is similar to a compute instance where you have full control over the configuration, but what's different is that this is a multi-node cluster of virtual machines that can scale as needed. This makes sense considering model training is typically done with larger amounts of data. And by using a multi-node environment that can scale and take advantage of parallel processing, we can process our data much faster. We can also use serverless compute to accomplish the tasks of doing model training or doing pipeline jobs. Similar to serverless Spark compute, this compute is also a fully managed on-demand style of compute that you can use for training jobs. In other words, there's really nothing to configure for this. We can just use it, and similar to a compute cluster, the serverless compute environment will scale as needed to do the work. This can be a great advantage to minimize the amount of operational overhead that you might need to do. As well, another great advantage is we can specify the size of the compute that we need at runtime, rather than having a specific configuration like we would with a compute cluster. And one of my favorite features is that if we have a second job that's starting, it would get a new node or another cluster to start running the job. So we would have both jobs running in parallel. Whereas if we were using a single compute cluster, the second job would be queued behind the first job. Next, we have Kubernetes clusters. Later, when we discuss environments, we'll see that Docker containers are typically used to specify the environment. So it makes sense that we could leverage a Kubernetes cluster to provide parallel compute by hosting the Spark-based cluster by running multiple container nodes in the Kubernetes cluster. What's interesting about this compute is first, it gives you a lot of control over the environment, including the ability to host many different types of workloads in the same Kubernetes cluster. It also has a second advantage that can be useful to connect to an Arc-based Kubernetes cluster so that we could potentially connect to a Kubernetes cluster that is on-prem and use that to provide the compute. Next, we have attached compute near the bottom of the slide. You notice that it covers doing experimentation, training, and doing pipeline jobs. The reason for this is because attached compute allows us to connect to existing compute in Azure, such as an existing virtual machine or an Azure Databricks cluster that is outside of our machine learning workspace. The typical reason we might use this is because we may have been doing machine learning or data engineering workloads outside of the machine learning workspace, before maybe it was even created, and we already have that compute existing. One example might be that we're using Azure Databricks for a while, and instead of creating duplicate compute, we simply attach to the existing compute. Lastly, on the right-hand side of the slide, we have containers, which can be used to package our models when we deploy it to a real-time endpoint, where we can host the container a few different ways. We'll be looking at deployments later on in the course. With that, let's jump into a demo and see how we configure compute. All right, let's talk about compute. So earlier we saw the data that we're using before. All right, now you can't really do anything with the data until we have compute to really go with it. So one of the things I'm going to do, I'm going to use this in just a minute, is I want to go make a small little file. You'll see why a little bit later. There's this compute setup shell script that I made, right? And I previously made it, so I'm just going to use it again. So right in here, it's just a git clone command. All right, just so you know what's in this. You're going to see this a little bit later when I go to create the actual compute. So it's just pulling that down. Again, that's the repository that we have all of these notebooks and everything that I've been playing with. So feel free to go and clone that if you want to on your own environment. All right, so that's there. So let's come down to compute. And what we're going to do is, this time I'm going to use the interface for this. We're going to make a brand new instance for compute. So let's do new here. And just give it that a second. It just needs to refresh. Let's give it a name. So how about Neil's demo compute? And here is just what type we want. We have the what size. So I just grab the standard DS11. So there's a bunch of recommended sizes here, but we can play around with this. You can see the pricing. A lot of different things about this. This is going to be a choice that you need to kind of sit down and think about a little bit. How big do you want this to be? Because the bigger, the faster. If it's GPU, for example, it's going to be more expensive. But at the same time, we're also probably running through a lot of data. For doing experimentation, for example. So that's it's up to you. All right, next page, scheduling. This is, I think, probably the most important feature that we really have here is this enable idle shutdown. So shut down after, in this case, 60 minutes for the default. So if a data scientist walks away from this compute, if it's idle for that long, it's going to shut down after an hour. Now, what what number should you have here? It depends. If you have it for something like 5 minutes, if they run for a coffee, it's going to shut down. When they come back, they're going to be mad because they got to wait for it to start up again. So something that's reasonable, but at the same time is helping to minimize the costs that are associated with everything. So you can change that if you like. Right. Another thing in here too is it is possible to create a schedule that you can start and stop the virtual machines on a particular schedule. I've had customers that say, for a data scientist, instead of using that shutdown time, we actually just set a schedule to say, from 8 a.m. to 5 p.m. we do that, but that's up to you. All right, next up, security. So this one, we can assign this to another user. So if I'm more of a compute operator, I can create this, set all the right settings, and assign it to a data scientist of one. There's also things like managed identity. There's managing on a virtual network. As a data scientist, this is going to be probably outside the scope of everything, so we're just going to skip over that. All right, next up, applications. It is possible to add applications into this compute instance. In this example, you notice in the setup scripts, there's 2 setup scripts that we really have. There's a creation script in here, as well as a startup script right below that. So the creation script is going to be when we first create the virtual machine. Basically now, this script will go and run and help create the machine. The startup script is going to run every time the machine starts up. So whenever it stops and then starts again, that script would run over and over again. So in this case, right, instead of using that startup script, if you remember that shell command that I had, that was actually a creation script. So once we do the get clone, it's like a one and done, right? So let's actually configure this to do our get clone. Now I already have a file for it, so it's just a matter of me pointing to the file. Say, yep, there's the compute setup that we made. That's why I showed you this earlier. And we could pass any arguments, anything like that. There's a timeout setting for it. And that's all we really need to do to say, when you create this, here's the, all of the commands I want to run, for that. So let's move to the next page. There's really not too much to this to provision it. The next page is just tags, which we do for all kinds of resources, and then we review it. All right, and let it go create. That's it. That's it. So pretty easy to work with. And then we have another compute instance that we can kind of work with within our workspace. All right, so that's going to take a tiny bit to go and create. So while that's going, let's talk about compute clusters. Right, so that's another tab in here, and it's possible to do this with the interface as well. Just make a new one. Very similar process. However, just to change things up a little bit, let's do this maybe with, how about we do this with the Python SDK, right? So let's go over and use a notebook for this, just so we can see it done a slightly different way. And it should be this one, yeah, create a compute cluster. All right. So what's happening in this one, right? The compute cluster. Actually, let me go back, make sure some plumbing is done first. Make sure that's all usually done fine with these notebooks and machine learning, but we do need to make sure our credentials are done. And it's really the next one that we want to make sure we have the ML client, because that gets used in a lot of the script, a lot of the cells later on. All right, once we do that, so coming back to the create a compute cluster, this is an example of doing this in code in the Python SDK. So we need to import AML compute. We're going to give it a name, right? So the name assigned to it, so AML cluster in this case. If we already have one, it's just going to really update it, right? So, or say, hey, it's already there, and I believe I already have one in this case. So we'll see in a second, but this is much more about the script. So let's talk about that. When we make a new AML compute object, we're going to specify what type it is. It's going to be AML compute. So that's our cluster. We're going to give it a size. We can set the settings like min instances, so the minimum number of instances when no jobs are running. We like 0. a lot of the times. Max instances equal to 2, so it'll only scale to 2 nodes. And then the idle timeout before scaling down. So clusters are really much more on demand. So in this case, it'll be 0. When a job is scheduled to run against it, it's going to spin up. But then once the job's done, it's going to be 2 minutes before it shuts itself down. And then we also have dedicated or low priority. So you see this one is set to a dedicated tier. The big difference here is that low priority is when we have extra capacity in our data centers, right, really in our regions, we will put compute on sale. And so it can be at a bigger discount. It's kind of prorated for how much capacity we have spare. But the catch is if we start running low on the spare capacity, because we budget for a lot of it, we might take that back. And so that's why there's a little note there that there's a chance of job termination here, because we may actually preempt these machines. So if you have a workload that you really need to be done, you're going to want to leave this as dedicated, for this. If it's something that's a little more nice to have, then maybe we use a low priority to get those savings. All right. So this one we'll leave at dedicated, so we have it. And then the last thing, of course, is just we're going to do the begin create or update command to get this compute going. So let's go and run this. Let's come up to the top here, give that a run. And you notice in this case, I happen to already have a cluster named that, so it's just going to reuse it. But if I didn't, that would have spawned and created everything that we just specified, so that works okay. Now, once we do have one, though, we can modify it. Now, if you recall, the code just above this already had the max instances set to 2, so we could change if we like, but I think you get the point, is that we can really say, hey, using the AML compute, specifically this named compute, here is the change I want to make, right? So we can update these values like the max instance, because it's begin create or update, it's update. So when I run that, we get, that's going to go over and configure that. So that's not really a change in this one, but theoretically it absolutely could be. All right, as well, we can view these values. So if we get a specific compute cluster, we can pull off any of the values, like you see the name and the max instances here being outputted as a string, so maximum 2 nodes. All right, next up, now this is going to be a little bit bigger. So this is, without really getting into the details of it, this is a training script, and this cell is going to write this out as a Py file. So we have everything we want to do in here. So it's scikit-learn, and it's going to basically train the model and all that stuff. So we ran that. That wrote out a file. Now, the reason we did that is really to show this next part. So that file is going to get used as a command in a command job against the compute that we just defined, right? So all of this together is going to get to do that. So this one will run. We'll talk about jobs and everything later on, but the point is that we now have a job that was submitted. That compute cluster is actually going to spin up to take care of the job, so the job will be waiting, and then we can sit and monitor it to see how that's going. So that's actually just at the bottom of the output down at the very bottom here. So you can sit and wait. Now, one thing about this is that it typically takes a number of minutes for that compute cluster to spin up, and then we can start using it. All right. So I think we're pretty good here. Why don't we go back to some content and talk a little more about what's up next. Just to wrap up this section, remember that compute instances can only be assigned to one user. A common practice is to have people assigned to the Azure ML Compute Operators role that create compute instances and then assign it to the appropriate data scientist. Another best practice is to review your compute settings to ensure that we are minimizing compute time and just overall being efficient. So when it comes to a compute instance, We can manually start and stop it, but if a data scientist forgets to stop it, we might be incurring a lot of additional costs that we don't want. So to avoid that, we could schedule the compute instance to start and stop at specific times, or, and I think this is the better option, we can configure the compute instance to shut down after a specific amount of inactivity. One of the challenges when doing machine learning in general is to control the environment. What I mean by that is when we're doing something like model training, are we being consistent with the different packages, libraries, and dependencies that we're using to do the data transformations or model training? This is what defining an environment in the Azure Machine Workspace is all about. An environment is used to define the context, and what I mean by that is everything about the environment, such as packages, libraries, and dependencies that we want to use to run our workloads, such as model training. By using an environment, we can be consistent in the configuration of performing the same task repeatedly. When we create an environment, we're actually creating a definition for a Docker container. The Azure Machine Learning Workspace comes with a number of curated environments, basically pre-configured environments that we can just use, assuming that it has the configuration that we need. Or we can also create a custom environment where we get control over what is being loaded into that container. When we create a custom environment, we're really just configuring a new Docker image. So we can do this by using a Docker file to specify the configuration, or we can use conda YAML files to define the configuration as well. Both of these options can give you full control over exactly how the environment is being configured. Let's take a closer look at using environments in the Azure Machine Learning Workspace with a demo. Let's go. All right, so let's look at environments in the portal here. So environments are used to really, provide that well, as it says, environment, and when we're running like things like jobs and whatnot, say this is the setup that we really use. And so we have curated environments, and then we have custom environments. So curated environments are ones they're already built, right? These are kind of out of the box. We have a number of different configurations for them, and so you can browse through this list, or probably even easier is just simply search. And so let's do a search for maybe like something like TensorFlow, and we'll see that it will filter down to some environments. And this also picks up on tags as well, so you can see that these are actually tagged with TensorFlow as well. So a search is actually usually pretty good for all these, and the source of on these are all listed as Azure ML. Okay, so these exist, right? And as long as we know that which one we want to use, we can test it. It's just really fast to go and grab one of these because we can refer to them. We can do custom environments as well, though. And this is where you're going to get a lot more control over what's in there. You can do this in the GUI interface. I'm going to show you this in a notebook instead. But it's kind of a yes, you can. You can go through and create it, specify what packages and everything you want installed. All that configuration is going to be pretty good. But the easiest one is definitely curated environments. That's probably going to work in most cases because if you know which library you're really using, like scikit-learn or TensorFlow in the version, you could probably find one of the environments to work with that. Okay, so let's go over to a notebook and see how to work with this a little bit more. So just a little bit of plumbing that make sure it's all there. We get the notebook kind of connected as well. So let me come down and do that. Right, and again, the ML client. So, I forgot I ran all that, so it's all good. So run a script as a job. So this is going to write out a training script again. And so we have everything in here. I'm just going to run it. We'll talk a little more about training scripts later on. But the point is that this training script is going to be used within a job. So similar to the last demo that we did, this is going to create a command job. It's going to point to the source directory and then specifically run the Python command on that Py file we just wrote out. Now here's what we're really talking about. So the environment that this is going to use, it's the Azure ML, scikit-learn 0.24, etc. It's this curated environment for it, and we're gonna use that environment against that compute. So how does that kind of work, right? Isn't the configuration part of the compute? Well, the environment is really a Docker image that's going to run with that. So, so that's really just curated, Docker images for it, and so we can take that, we could submit it. All right, so let's go do that, and it's going to run that Python file within that environment. Okay, so we can also list all the environments. And these are going to be all the environments that we have. You'll notice that when we list them, that there's these will have this Azure ML at the beginning of it. So right here, anything with Azure ML dash in front of it is a curated environment, right? So a lot of the common environments that we typically see are going to be listed here. So PyTorch, et cetera, are there. All right, so pretty good list, I think, for most cases. But again, if it doesn't work for you, you can make your own. So, you can retrieve one of these environments if you want to take a closer look at it, right? Let me just fix a little typo there. There we go. So, so we can pull one of these environments, see the tags, see the description. We can do all of that programmatically if we like to. All right. But as I keep saying, if it doesn't work for you, if the curated environments don't work for you, then we can go and use a custom environment instead. All right, so how do we do that? This is basically just a Docker image. So you'll notice that the environment that we're creating is based on a Docker image that's already existing. So wherever you want to kind of use as a base, we're going to give it a name and a description, and create this. Now, in this case, this is very simple. We could go a lot further and say, well, let's build a new Docker image that we pull from our own repository and do all that. But we'll keep it simple. Let's just run this, and we'll get a this environment is now created, right? So let's go and see that get used. All right, so you notice that up here, the name, just a reminder, it's Docker image example. So coming down to this next block, notice the name of the environment, Docker image example, and then basically what version it is, right? So :1, and that's good. And this is just running another job, right? But this is going to use that Docker environment instead. Okay, so that works, right? This job is now submitted, it's off to run, and it should be just fine. So just a reminder, we can build these, to have a lot more in them. So it's really, you get the control over that Docker image, however you want to manage those. Okay, with that, let's jump back over to some content and wrap up this video. This concludes this video, where we covered a lot of the core configuration of the Azure Machine Learning Workspace, starting with introducing its resources and assets, showing you how you could work with the workspace using the Python SDK or Azure CLI, and then we discussed making data available to the machine learning workspace. How to configure compute and the different options there, and we finished up with introducing environments and what they represent in an Azure Machine Learning workspace. I hope that this video has been useful to you, and I hope that we see you again as you continue on through this training series. Thank you for watching.